Okay. So now our new topic is STP, spanning tree protocol. So what we will do, what we'll achieve with spanning tree protocol. Basically, if we have a single path, there is no loop. We have like single path from switch 1 to switch 2. Here, this is a switch 1, and we have another switch. This one is a switch 2. If we don't have redundancy path, so no issue here. In these switches, no issue. But if we have a redundancy path in between switches, then automatically the one path will be disabled. It's a spanning tree behavior. So because of spanning tree, what it will be do, avoiding the layer to loop. So it is by default enabled in Cisco switches, and it is an open standard protocol by default. So STP work based on the spanning tree algorithm, avoiding the switching loops, that is layer 2 loops. So bridge, we call it as a bridge or switch. You can call it anything. So earlier we call it as used like this word bridge. Now in traditional network, we are using like switches. But whenever we are discussing root bridge, it again root switch only. Root switch means it's a master switch in our LAN's network. So if we have 100 of switches in LAN network, only one switch elected as a root switch. Only one switch will be election as a root bridge. Apart from that, all the switches are not root bridges. All the switches are the non-root bridges. So by default, if we don't have redundancy path, then also we have a issue, single point of failure. If this link went down, if this some happen with this link goes down. If we don't have this path, if we don't have this path, it's a single point of failure. PC1, he cannot communicate to PC2 because of it's a single point of failure. So that is the reason we need a redundancy path. So even though not only one path in real time, we have a multiple paths likewise. So this is a first path and second path, and it's a likewise we'll use multiple path. If one path single point of failure also, we have a redundancy path. So by default, loop will be occur because switch behavior is broadcast the information. So broadcasting means they'll send the packets to every port, every line, every port or every wire they are sending the packets. So it will be received, it will be sent again this link, it will be received likewise. The loop will be occurring by default. So avoiding this loop, avoiding this layer to loop, we have a protocol that is STP. This is all about basic of STP. Now move forward, and how it will be election, how the root port will be elected, and what are the port roles, and what are the terminologies in STP. So first I'll show you some terminologies in STP. STP terminologies, what we will discuss here today. Today we will discuss these terminologies. First we'll discuss root port, how it will be elect. Root bridge, first we'll discuss root bridge. Root bridge, it means again switch. Root bridge or switch, root switch you can say, no issue. And we'll move, then what is BPDU, bridge protocol data unit, we'll discuss. Then we'll move forward, and cost, what is cost, and what is the use or what is the cases, and when we'll use the cost, how the cost will be happen in STP we'll discuss. Then root port and designated port. First we'll discuss root port. And apart from that, we have a designated port. You can say this is a RP. Root port means RP. And designated port. And one more port also we have, blocking port. With this blocking port only, our traffic whichever here just now we discuss what are the switch behavior. Here we have a single path. Then here are no issue. If we have a redundancy path, so in this path 2 we have a redundancy path. These are switch 1 and switch 2. So one, if this is a root bridge, RB root bridge, this one is a root bridge. So root bridge have all the designated ports only. This is the DPs, all the DPs, and this one also DP. Only this is a non-root bridge, having only one root port RP. Apart from that, all are the blocking ports. If these port have one more port, this is a blocking port. The blocking port, as we call it, is a alternate port. If we have multiple, how many? If we have 2, 3, 4, 5, how many we have? Those all are the alternate port only. That is, we call it as a port role is blocking. So anyway, we'll discuss. So these are the port roles. First, we'll move how the root bridge will election happen. How the root bridge election will be happen. So here in STP, so by default priority we have, that is priority 32768, the priority, and plus MAC address. So based on this priority and MAC address is equals to, will get bridge, root bridge, RB, root bridge. So priority is a priority and plus MAC address is equals to, will get the root bridge. How the election will be happen? So first of all
Hey
the
Siri,
bridges
call always
generate
Siddiqui.
the BPDU packets, BPDU, Bridge Protocol Data Unit. So here I'll show you something on description. So spanning tree protocol, it's a layer 2. So it is used to get loop-free topology on layer 2 devices and multiple paths
Always
available.
laughing
If
at
we
you.
have a multiple path, so it will be avoiding the loop. So single point of failure, if we are having single path, so if we have a redundancy path, so we need to loop avoidance. So spanning tree, that is what it will be doing. It is a layer 2 protocol again, and it is an open standard protocol. The code is 802.1D. The code is, it is a standard protocol, means the code is 802.1.1D. So we have a another protocol also, that is like 1Q.1Q means it's a trunking protocol, like it's open standard, like 1Q. Likewise, here we have a code 1D. So it only provides a single path, not a multiple one in our topology. So if we have multiple paths like 1, 2, 3, 4, 5. In these two switches, we have a 4 path. So in this 4 path, only one path, always it is a forwarding path. Apart from that, all are the blocking ports. All are the blocking alternate ports. In this non-root switch, only one is the RP. Apart from the all are the blocking only. So that is what only one path is forwarding path. And root bridge switch election, how it will be happen. So a switch device with the best bridge ID, best bridge, that is means lowest priority or lowest MAC address. Best bridge, it's mean lowest, whichever the having the lowest bridge MAC address. So here as I told, so by default priority is 32768. If 32768 is by default, if you want to check, I'll show you in real time. So I'll open lab here. So here you can check by default priority is actually 32768. So if we have multiple VLANs, like if we have 32768 plus whichever the MAC address is there, it will be add on that plus one. If VLAN 1 is by default 1. If you are having the VLAN 10, 32768 plus if you are using the VLAN 10, it means it will be add like 10 plus 10 means 32778. The value it will be like, it will be happen. It will be show like 32778. Likewise, here it will be 32769. It will be result we will get likewise. So it will be add on likewise. So this is the by default priority is the 32768. By default priority we have 32768. So here we can check. I'll use one topology here. What we are discussing now. I'll take two switches. First, I'll use one path only. And I'll take two end users here for reference part. So first I'll take only one path in between switches. So fast Ethernet 0/2 and fast Ethernet 0/2. So here you can check spanning tree protocol with the help of this command. Enable show spanning tree with this command. So here you can check learning state. We'll discuss what is learning, listening. So show spanning tree, learning state, still learning state, and one port is came to forwarding state. You can check here, forwarding state. So forwarding state, these are the role. Just now we discussed designated port and root port. So in this bridges, one bridge as one switch as elected as a root bridge, how we can verify it? First of all, how we can verify the which one is the root bridge? Here we have a two switches. So here we can easily find out. So in these switches, one is the root bridge, and apart from that, another bridge is a non-root bridge, non-root switch. So here we can check the by default. So this is the MAC address is varying. It will be based on the vendors. It will be give the different MAC addresses we will get. But here you can check the 32769. Just now I told the based on the MAC VLAN IP address, it will be add on. So VLAN 1 is by default, it is showing. That is the reason 32769. So just now I have mentioned here. So if VLAN, so by default priority is 32768 only. Plus it is add on the VLAN. So that is the reason here we are getting the priority value is 32769. If you want to change the priority, yes, you can change it. No issue on that. How we can change? Config T and VLAN 1 and spanning tree. Spanning tree, VLAN 1 and priority likewise. So again, here if you want to change the priority, so add on like the value will be always 4096 place 4096. Add on likewise. Whichever the values you will get 4096 only. Always we have to use 4096, the value. It is a by default a range we have to use. So if you are changing zero something, it won't take. So if you want to check, so we'll check the values. If I am giving the value priority, try to changing the priority something here. So here, so 4096, as I told, though whichever the priority you are trying to change. So in real time, not recommend also. Just I am showing how if you got a scenario here, you have to change the priority. So likewise, we have to use. So if you are trying to change 100, it won't take. So we have to use the values 4096 plus add on 4096 plus 4096. You will get the value 8192. Again, add 8192 plus 4096. You will get the value this one. So the range will be add on plus 4096 only. So by default priority we have 32768. This is the value. If you want to change the less value, less will be best. Less will be best. By default, this bridge is not a root bridge. So by default, this bridge is a not a root bridge. If you want to check, this bridge is a root bridge. How we can verify it? I'll show you. Then I'll change the priority. Then you can verify it. Show spanning tree. Here you will get this bridge is a root. So root bridge having the root port also, bridge ID also. So here bridge ID means the local bridge. The local bridge. So this is a bridge. Here you can get that this is the bridge ID information. This is the own bridge ID information. And this one is the root bridge information. You will get if you have 100 switches in your topology, so you will get same information here. Same information you will get. So this is a root bridge, MAC address, and cost. We'll discuss what is cost and all. Before that, it will be based on the least MAC address and least cost. It will be least priority. It will be elect as a root bridge. So the MAC address is here. This bridge having the MAC address is here. If you want to check the MAC address, so we have to use a command show version. So with this command, we can verify the MAC address also. So you can verify it. So MAC address is 0010971C. Here you can verify it. 0B D0. Something like this. Here we'll get. So version. So here we will get the MAC address of details. This is a MAC address. And by default priority, as we discussed, 32768. And this is a by default priority of 32768. By default priority. Having both switches, the by default priority is 32768 and 32768, but MAC address is different. MAC address is different. Based on the MAC address, it will be elected. So you can check here from starting onwards. 0060. Here you, instead of 2 digit, here 00 is there, third digit is changed. So here 6 and here 0. Which one is less? 0 is less. So based on the MAC address, it has elected as a root bridge. Based on the MAC address, it has elected as a root bridge. Likewise, we have to verify. So this is a root bridge. Again, show spanning tree. So here you can verify this bridge is elected as a root bridge based on the MAC address. Based on the MAC address, it will be elected. And don't confuse here 32769. Whenever you are seeing, if you are confused, if you can check the VLAN 10, the value will be vary. The value will be changed. So if you are using 20, the value will be changed. If you are using VLAN 20 or 30 or 70 or whichever the VLAN, it will be add on that VLAN ID. So here the based on the MAC address, it has elected as a root bridge. Now move forward. How the port is blocking here. I'll add on one more port. So here you can check the spanning tree election is processing. show spanning tree. So here you can check the port is fast Ethernet 0/3. Now listening state. Now listening state, after then listening, the listening state still it will be take 15 seconds, and learning state it will be take 15 seconds, and learning state still learning state it will be take 15 seconds. So why it will be happen we'll discuss. So still learning state, here you can verify fast Ethernet 0/3 port. So now it is blue and one is amber color. So orange color, amber color, you can see. Can check here. One is amber color, one is green color. Here you can check. One is amber color, another one is green color. So as we discussed, root bridge having all the ports are forwarding ports. So spanning tree. And forwarding ports, it means designated port, and designated port. Leave about the this port. This is the edge port, and these two ports are connected by switches, connected through switches. So both are in forwarding state. Now verify on this switch non-root bridge. This is a non-root bridge. Show spanning tree. Here you can check. This is the alternate port. Port role is alternate. It means it's a blocking state. Now it is in blocking state. It won't send and receive the information. Once the whichever the forwarding port went down, which whenever the forwarding port went down, then it will be come to the picture. Otherwise, it will be still the port is like blocking only. Now we'll change. Sorry, some internet issue, I think so. So here you can check this is a root bridge, and same information you will get on non-root switches also. It's a non-root switch. So here you can verify. So with this ID, with this MAC address, you can verify it. 0B D0. So this is the root bridge information, and this is the local switch information, local bridge information, whichever this is the MAC address of local switch, and you can verify here CEAA. This is our local switch. Now what we'll do, we'll make it. This is the root bridge. How we can uh, change the root bridge. So simply we'll decrease the priority value. So lowest priority is the best here. Whichever the having the lowest priority as well as lowest MAC address. If priority match, then it will be priority is tie. If see here, priority is same. Both are having the priority is same. So based on the MAC address, it will be elected as a root bridge. This one is elected as a root bridge. So we'll change the priority now. So what we'll do, spanning tree and VLAN 1 by default VLAN, and we'll change the priority. So priority is the value we cannot change like 100 something. We have to use the value whichever the set by default 4096 or 8192 or 12288 163484. This is the values we can. So 4096 I'll take here. So now you can check. Here the port earlier both are in forwarding state. Now you can check here. Show spanning tree command. Now one port is blocking now. This is the root bridge. Earlier, this is the root bridge. You can check the commands in between. So this is the root bridge earlier. Now you can check the root bridge is gone. No, this is a not root bridge. Root bridge information is available here. You can verify. CEAA. Now you can check here. This is the root bridge. Show spanning tree. This is a root bridge, and all the ports are forwarding ports. Now designated ports. You can check forwarding and designated ports. This is a root bridge. Now we can verify. Earlier, this is a non-root bridge. So this is a root bridge information. Now you can check the both MAC addresses available in this switch only. So likewise, we can change. Any queries? How we can change the root bridge and all? So how the root bridge election will be happen? Simply use this command. If you want to change the root bridge, use this command. I'll paste this command in chat. Okay. Now move forward. What is BPDU? BPDU, Bridge Protocol Data Unit. So this is how the bridge, the MAC address and bridge ID selection happen. So now move to the bridge protocol data units. So at very first time, all the switches in the domain will generate BPDU and send to all the other switches in the domain to for election of root bridge. Root bridge switches always generate hello messages after every 2 seconds. That message is called BPDU message. So first of all, whenever the topology occur, so just now we created one topology, like we have a one switch and another switch and we have another switch here. So all the switches originated BPDUs, Bridge Protocol Data Unit. All the switches they will originate. So they introduce themselves. So I am having my priority is 32768. If this switch is telling my priority is 32768. I place my VLAN. I do have this many VLANs IDs. So I have one VLAN something. So same thing. This switch also BPDU and 32768 a place MAC address. In BPDU content, this message will be happen. So, and apart from that, we have some messages also, some version also, some it will be carry. First, they will tell, I do have this much information. I do have this much information. First, they send every 2 seconds till root bridge election done. Till root bridge election done, they will send this BPDU messages. Once election will done, then root bridge only send the superior BPDUs. We'll discuss those things. But so first of all, whenever the topologies occur, first they will send BPDU messages. BPDU hello messages. These all are the hello messages. BPDU hello messages. So in this, some content, some information will be carry. What those information will discuss. But first, they till root bridge election happen, they will send every 2 seconds. Once election done, this will be take minimum 20 seconds. It will be take topology convergence minimum 20 seconds. It's 20 seconds, the topology convergence will be happen. In 20 seconds, the topology convergence. In this topology convergence, they will carry this much information. They will carry, this is the information they will carry. So initially, all switches generate configuration BPDU to advertise them as a root bridge. They plan to advertise because in this first time, if all the switches, in this topology, they don't know which one is the root bridge. For root bridge election only, they are sending. I am having this information. What you have? I am having this information. What you have? I am having this information. What you have? They are sending hello messages with through BPDU messages through BPDU. With this is the protocol, bridge protocol data units. Through this protocol, they are sending. I am having this information. What you have? Once they will find out. So this is having the best MAC address. This is having the lowest priority. So we'll elected them as a root bridge. This is the they will agree. Yes, this bridge having least MAC address, least priority. So we'll announce themselves. This is the root bridge. Likewise, whichever having the list, they will announce them. So they will also understand this is the root bridge. Whichever the information we have to surround it. We have to give the root bridge one. Then root bridge only the master bridge in topology. That bridge only having the designated ports. It means that port only originate after then every information, all the information means BPDU information, superior BPDU information, that bridge only originate. So after root bridge election, only root bridge generate configuration BPDU. In this configuration BPDU, what the content will be happen. So protocol ID, whichever the version, which version we are using, STP version, and BPDU type. Here we have two types of BPDUs, topology change notification BPDU and configuration BPDU. Two types of BPDUs. In this BPDU, the root bridge only generate the configuration BPDU and flags, root bridge ID, root path cast, sender bridge ID, sender port ID, hello timer, message age, max age, forwarding delay timer, entire information. This is the entire configuration information will send root bridge only. The authorized bridge, it means master bridge. If we have in our topology, how many switches? Only one as a root bridge. That bridge only send the entire information. So here we have a topology change occur. So this is a cast value. So by default cost, how we can verify, I'll show you. Though, so two types of cost we have, 16-bit and 32-bit. By default, 16-bit we are using. So Ethernet 10 Mbps actually the link, and cost is 100 Mbps. This is a STP cost. And this is the speed of the fast Ethernet 0 by fast Ethernet port is 100 Mbps. Gigabit Ethernet port is 1000 MB. 1 gig means the 1000 Mbps and 10 gig means 10,000 Mbps. How can verify it? So here you can verify. I'll show you that before once we'll complete the topology change notification. If any changes occur in STP topology, if any changes occur, TCN BPD means topology change notification. Any changes occur. So non-root bridge will generate TCN BPDU. So just now what we did here, so we'll make it, this is a non-root bridge. So with this command, what we did, this we configured, we change the priority. So this bridge has changes. So TCN topology change notification is originated. Some message is originated. So I got some least priority. So now you are not the root bridge. Now onwards, I am the root bridge. So that likewise the notification he originated. That is the topology change notification. So this kind of notification, who will change, who will originate non-root bridges, and configuration BPDUs, who will originate the root bridge, whichever the root bridge have, that will be originate the notifications. Sorry, no configuration BPDUs. In that content will be happen. So priority, so protocol ID, version, and BPDU type. In this BPDU type only, we have a content of whichever the entire information. So likewise, the BPDU will originate. Now we'll check the root port cost. We'll verify this thing. So here you can check the cost value is 19 because of is a Ethernet port, fast Ethernet port. So fast Ethernet port show interface fast Ethernet 0 by 2 we are using. So here you can check. So 100 Mbps. Here you can verify the 100 Mbps. So it's delay time or something bandwidth if you want to check, and kbps it's 10,000 or something. Likewise, it's lakh, not 10,000. It's a lakh, 1 lakh. So 1 lakh kbps means it's 1000 mbps. It's a 1000 mbps. So 1000 mbps means here we'll get the value is like 19. So by default, this is the value we'll get. It is a STP standard. These are the STP standard values. If you want to check the gig port, so as we can verify it. If you want to verify the gig port, show IP interface brief will verify gig port is available here. Yes, we have a gig port, gigabit Ethernet 0 by 1. So show interface gigabit Ethernet 0 by 1. Here you can check the 1000 Mbps. If you are using the gig port, so I'll use the gig port again here. So this is a gig port. Now we can verify it. Cost value, show spanning tree. So here you can check. the cost is 4, as we discussed in theory. Cost is 4 and speed is here. You can check 1000 Mbps. Likewise, we can verify it. Still it is in learning state. Show spanning tree. So still learning. Show spanning tree. Still learning. So these all are not required in real time, even though we should have to know if interviewer will ask this kind of questions. So here you can verify. Now forwarding state. Even though in this switch also forwarding state because of speed is vary. Earlier the blocking port you can verify. This is the blocking port earlier. Now this is only the block forwarding port, root port. Apart from that, all the blocking ports you can verify. Show spanning tree. So now you can verify this is a first gig port. So 4 cost is 4. That is the reason it is root port. Now root port based on the cost also it will be elected as a root port. You can check here root port elected forwarding, and root port is not available on the root bridges. Root port available only non-root bridges. Again I am repeating, root port is only available in non-root bridges. If you want to check in root bridge, this is a root bridge, this one is a root bridge, there is no root port. RP is not there. Only RPs are available in this non-root switches. RP available. Only one RP is available. Apart from that, all the alternate ALT, alternate ports. And these all are the forwarding ports. It means DPs, designated ports. And root port, root bridge, sorry, root bridge, this is a root bridge. Actually, root bridge only having all the DP ports, even though not in single root port, and designated port only forwarding the superior BPDUs, and RPs will receive and forward also, and whichever the alternate ports are there, these are the blocking port. Those are the blocking port. They will not forward and they will not originate also. So here you can check. These are amber colors. Fast Ethernet 0/2, fast Ethernet 0/3. These are the blocking ports now. So apart from that, so here we'll check port roles. Before that, this is so root path cost. Just now we discussed. There are two different methods available to find the root path cost, and by default, STP uses short method to find the value. This is a short method. So this is a short method. We have a 10 gig Ethernet method. Ethernet having 100 and fast Ethernet having 19. This is the cost. There are three port roles STP protocol we have. So first root port and designated port. Apart from that, alternate port. Just we discuss here. This is what. So here you can verify. So first one is root port. So best interface to receive the BPDU packets. This is the best. It will be receive the BPDU packets. Who originated the root bridge originated, it will be received. So through root port only we receive. On a switch device, we can have only one single root port. Yes, we have only one single root port. Apart from that, all are the blocking ports. On a root bridge switch, we will never be having the root bridge. So whichever the root bridge is there. So this one is a root bridge. As we discussed, in this root bridge, we don't have the root ports, RPs. You can verify anything is the root ports. Only all are the DPs, designated port, port role, all are the designated port only. DPs is there. So just in this switch only, we have a RP. Only one RP is available. Only one RP. If we have multiple switches, so now what we'll do, I'll take one more scenario here. 1, 2, 3. And I'll use connectivity in between switches. So it will be take minimum 45 seconds because topology convergence, it will be take 20 second, and listening 15 second, and learning 15 second, and forwarding. After then forwarding, it will be take minimum 45 seconds. We should have to wait. We don't if you want to change, yes, we have a uplink fast, and those are the commands we have. So recommend you those we haven't used. So if you want to change it, edges means host. This host, we have a command. So we have a command. If you don't want to waste here the 45 seconds, yes, we have a command, port fast command. Just enable in real time. We'll enable port fast command. What is that? What is the use of that? We'll discuss. Before that, we'll finish the root bridge election. This is the root bridge, how it will be happen. Show spanning tree. Just here, this bridge is root bridge. You can verify 001 D0. You can here you can check, this is the root bridge. If you want to check the MAC address version, so 00D0, and this bridge having MAC address is show, because here the priority is matched. So here you can check 7 3, the value is more, sorry, 00E compared to D, E is more. So here you can check, show spanning tree. Here also D is there. Sorry, version, show version. So here it is the here also E. So this also bridge having E, and this bridge also having E. So the compared to D, E is more. So that is the reason this bridge route as a, this is elected as a root switch. So spanning tree. This is a spanning tree. We can check, this is a command. Through command we'll verify. So this is the bridge having the least MAC address. That is the reason it will be elected as a root bridge. And these all are the information. Root bridge having this is the same bridge ID information also. So what will verify here? So cost done, and having forwarding ports. These are the forwarding ports, means designated ports. And this in this switch only one RP. Apart from that, designated ports only. Apart from the designated ports only. Show spanning tree. So here you can check only one root port. One root port is there. Apart from that, two. This is a leave it. This port. This is a span. We having the edge port. This also acting as like always forwarding port. This port is always designated port, because it should have to receive, and it should have to send some information. But he don't want to waste the timer of listening, learning, forwarding. He don't want to waste BPDU message. What is the requirement for him? The end user, not a requirement for BPDU messages. This user required or not? No, not required, because it is originating the original traffic only. It is not a part of topology. It is a part of user. It is a part of user. So this user don't want to participate in STP topology. So that is the reason we'll avoid the topology. Just one command will use here, config T. So we'll use interface fast Ethernet 0/3, and spanning tree. Here we have a port fast option. Port fast. Just will disable or enable. By default, it is disable. So just use this command. Here it is showing. So port fast should only enable on ports connected to single host. See, this is a single host. That is the reason. If we are connected to hub also, connecting to switch, bridge, etc., we cannot use those things on this interface. If it is we are using the interface, so I'll shut down the PC and I'll on. What will be happen? Earlier it has taken the timer. Now we'll turn off and we'll turn on. So within a seconds, it came up here. No election will be happen. Now another one I have taken. Here the election is originated. So here you can check the amber color is there. Some election is happening, but I'll turn it off with this PC. So I have turned it off, shut down, and I'll on. So here within a seconds. So here no election will be happen. Though CPU utilization also not much more. So switch CPU utilization also decrease, and this port having part of port fast way enabled. It means in real time also we'll do same likewise. So here he has taken 30 seconds. I'll shut down this PC. You can check. So it will take 30 seconds. The user still he want to wait. He should have to wait for 30 seconds. So 30 seconds means in real time it is more time, because so if we are running in a bank website something, so once this port went down, again port came up for some reasons of there, it is taking time. So this user cannot access that 30 seconds anything. So it is a wastage of time also. Even though in millisecond also it will be carry. It will be in real time. We have a SLA, service level agreement. Sorry, service level agreement means even they calculate even though single second also. So we don't want to waste our timer. So in banks websites or something, whichever the value users are there, so they don't want to waste their them time. So we have to use this port first future. So here you can check. Here you can check. So what will be happen here, some stages also there. So based on that stage it will be happen, we'll discuss those things. So first of all, and this is a bridge, non-root bridge only, and this bridge having one blocking port, show spanning tree. Here you can verify only one port is a forwarding port and root port. Apart from that all are the blocking ports. So here you can, if you connect one more port also, so one more port also, so it will be taken election. One port will be blocked and another port will be forwarding port. So this is a non-root bridge. Only one is a root port. This one, if this is a root port means this port will be blocking. Always this port will be blocked. Likewise only it will be happen. So if you don't want to waste this our infrastructure, so we have a option, that is ether channel. We'll discuss later on sessions, because here connectivity is we are wasting. So our port also we are wasting, our resources our also we are wasting, because here we are wasting our one more port. So here we cannot achieve the load balancing. So if you want to achieve the load balancing, so we have a option ether channel. So we'll discuss later on sessions. But even though that also it will be act as like one port only. So it physically two ports, but the logically that is the only one port. In if you are using ether channel also, logically one port means it's combining. It is combining as a two ports physically, but it is acting as like one port only. Anyway,
It
we'll
is
discuss.
combining only two ports, or it will combine a multiple port and make one logical link.
Yes, logical. Not two ports, even though if you are using more than four also, no issue on that. In real time, we'll use likewise only four ports. If one port is goes down, another port we have. So we are wasting our resources, right? So that is the reason we'll use in real time ether channel. Ether channel means that is a port fast. So multiple logical links, it will be combined as a one logical port. Sorry, multiple physical ports. These are the physical ports, right? Physical wires. This one physical wire, second physical wire, third physical wire, fourth physical wire. So these all are the four physical wires. It will be combined as one logical wire. One logical wire. So here you can check the configuration part. Show spanning tree. How many ports are there? Those all are the DPs. DP, designated port, all are the forwarding state. But in this switch, you can verify all are the only one is the designated port. All are the, apart from that, all are the blocking only. So only forwarding port is one. Only forwarding port, that is root port. Apart from that, all are the blocking ports only. All are the blocking port. So here we are wasting our resources. Later on session, we'll discuss what we can use this port, these cables also. No issue. But time being, just give me time. We will discuss later on. But here, So likewise, spanning tree will be work. So this is a root port and designated port and best interface to send BPDU packets. The designated port only will send the BPDUs, British Protocol Data Units. In this BPDUs, what content to carry? We already discussed here. This kind of content it will be carry. This is the content, and here a switch can have multiple designated ports. So root port, only one root port, only one single root port. Every switch have, but designated ports multiple we have. So in root bridge have multiple ports, right? So just now we discussed, and alternate ports also multiple ports. So the port which, so before that, root bridge switch, all the ports will be designated ports. Root bridge is root bridge ports. Root bridge having all the DPs only, all the DP ports only, and alternate port. The port which can't elect for RP and which can't be elected as a DP port. That port will be alternate. It means it is a blocking port. Alternate port will always blocking state. It will be always in blocking state. This is how it will be happen. This is the rules, port roles, and how it will be elect root bridge, root port election, designated port election. So here we have a two ports, major ports. One is root port, and one apart from that is alternate port. So here you can check. So spanning tree. So here we have a one is designated port, and designated port means lowest root port cost and lowest local bridge ID and lowest local port ID. Lowest bridge ID means it's will be whichever the MAC address and priority value. Lowest path cost and whichever the cost is there, lowest that will be elected. So how what does it mean? I'll explain in something different. So here I'll take scenario. We have one switch here and one switch here, one switch here. So this is a RP root bridge, RB root bridge, and as we discussed here, root bridge having DP ports. This is a DP and DP. DP opposite always RP, always root port, and nearest to the root bridge, nearest to the they will select. So here one more switch we have. So in this one is a root port and this one is a root port. Root port opposite we have a DPs again, designated port, and this one also DP, designated port. So in this scenario, one will be block, other will be forwarding state. How it will be elect? So first lowest root path cost. If we are using here fast Ethernet means 19. So here 19 and this one also F means FE means 19. So 19. So here also if we are using gig port means this is the 4 and here we are using this one is the fast Ethernet. Now you tell me. So 19 plus 19, how much? 38. So this range is 38. And this one is the 19 plus 4. It means 23. Which one is least cost? So 23. This one is the root port again. This one is the RP and this one is the blocking. Alternate. Blocking or alternate. Likewise, the scenario will be happen. Okay. This scenario likewise. Understood the scenario, how it will be elected? The lowest root path cost. The lowest root path cost is done likewise. We vary based on the whichever connectivity we are using, fast Ethernet or gigabit, that vary based on the cost. And lowest sender bridge ID. So here one more thing, if here also if we are using same port, here we are using 19 only. So here also 19 and here also 19. If we are using 19. If 4 is there, this will be root port. If 19 both are 19. So here we are using fast Ethernet and here also we are using fast Ethernet. So it will be elected based on the sender bridge ID. So if this bridge ID means, again, 32768 plus MAC address, whichever the least MAC address is there, that will be root bridge. In this case, in these two scenarios, the major first one is the root bridge only. In these two non-root bridges, whichever the sending root bridge, in that it will be checked whichever having the least MAC address. If this having the least MAC address 0010, if this having 0020, which one is least? Least. One is least, so it will be RP. Apart from that, this one is the alternate. It will be election will be happen. So then it will be move lowest sender port ID if both having the same. So in this scenario, not in this scenario, if we have one more scenario, I'll take here. So here we have one switch and another switch, another switch. So this is the RP root port and root bridge, and root bridge. This is the non-root bridge, and this one also non-root bridge. So here one port will be block RP. So this is the DP by default. This one also DP. DP is only because this is a root bridge. Root bridge having all the ports are DPs only, designated port. All are the forwarding ports. Apart from that, the non-root bridge having only one RP. Apart from that, only all are the blocking, otherwise designated port. This is the blocking because it will be election based on the sender port ID. If this is a fast Ethernet 0/1 and this is a fast Ethernet 0/2. So this port is least compared to this port. So this one is the RP and this one is the blocking. So it will be check the whichever receiving the information port. So based on that port value also it will be comparison will be happen. So it will also done. So lowest receiving port ID, it will be again the matches. If here it is will be matches, so it won't match, port will be not match. So receiving port ID, whichever the receiving, if we are means here you can check once it will be received. So first best example is for the receiving port ID. So fast Ethernet 0/0. If the election is not done here, so here we are using fast Ethernet 0/0 and fast Ethernet 0/2. Vary, it will be election on this also, receiving port also. Here you can check in this real time. I'll show you. Here we have the values. See 0 to 1 to 8 and here 1 to 8. The value is, this is the priority of port priority 128, 128, 128. So this is a port priority. So port priority here you can check. So this is a compared to other ports, this is the least port. So fast Ethernet 0/1. This is the least port. That is the reason it has elected as a root port. If some scenarios, it will be vary. Understood, everyone? So here it will be select whichever the receiving least port, it will be selected as a root port. These all are the root port election will be happen. So here you can check in this switch, we have a multiple path. Fast Ethernet 0/2, fast Ethernet 0/1, 0/3, 0/4, 0/5. So all are the same. This switch having the same MAC address, same entire thing same. So it will be not elected based on that. It will be elected based on the port priority. So port priority is 1 to 8. If you want to change, yes, we can change the port priority also. If you are decreasing the port priority, so that port will be elected as a root port. If you want to change, config T terminal. So interface fast Ethernet 0/2 to spanning tree, and here VLAN 1 and port priority. Here also we have to use decrement 16. If you are taking some value, it won't take. If you are taking 10 means it will not take. So port priority by it will be add on 16, 32, and likewise 64. Those values it will be take. If whichever you are giving, it won't take. If you are configuring up to 240, the major value 0 to 240 it will be take. If you are giving the 10 means it won't take. You have to give 16 likewise. So then only it will be taken. I have changed the port priority value. The election will be done. Once the switches down or something happen, that time it will be how we'll use something write command. Show spanning tree. It have changed port priority. Still it is blocking only. Once the convergence topology changes occur, then it will be moved to the forwarding state. So likewise, we can change the port priority also. Any topology changes occur, the time the root port or the ports will be changes. Show spanning tree. All are blocking state, still learning, listening. Anyway, it will be changed. So likewise, it will be happen and designated port election lowest root path cost. So it will be designated port and lowest bridge ID and lowest local port ID. It will be vary. So here we have. So we have a in this switch. I'll show you. Show spanning tree. So here we have a only one root port. Apart from that, all are the designated port. You can check here. So those are the LAN cable. We'll remove the LAN. So now you can check two ports only. So forwarding port only one. It will be elected based on the in this scenario. You can check in this scenario. It will be elected. This one is the root port because this bridge having the highest bridge ID compared to this bridge. So based on that also it will be elect, and based on the cost also it will be elect. So likewise it will be elect designated port. This is the DP again in this scenario. This one is a DP. You can check. This is a fast Ethernet 0/2. You want to verify? Yes, we can verify. So fast Ethernet 0/2. Yes, this is a DP port as we discussed. Based on the values, it will be elected. So now move forward. Any doubts in this? So here we have a port states. So mainly here we have a 5 port states. In that first one is disable and blocking state and listening state, and we have a learning state and forwarding state. So and STP block disable means it will be convergence. First we have started by default all the port will be there in disable state. Any data can't be sent or received if the port will be there is disable state. If we have manually shut down our port on the switch device, so that port will there is no disable means we haven't configured till STP or some port are went down some reasons. Those are the disable ports and blocking ports. And blocking ports means just now we discussed all the it will be not listen the BPDUs, and this is the ports whichever the these all are the blocking ports. Apart from that, non-root bridge having these all are the blocking ports. These all are the blocking ports. So here alternate port means blocking ports. These all are the blocking port. They will not listen or they will not send. They will not originate BPDUs and all. There is a state or AP port, alternate port. will not be in down state. This is not a down port. Actually, it will be ready to up only, because once the block means this root port, in case some reasons this port went down, will shut down it. Config T interface fast Ethernet 0/2. If in case this port is goes down, shut down. So shut down means this case, this is a disabled state, and this port will be come to the forwarding state later on. In real time, it will be happen. Okay. It is trying to come up. That is amber color. Amber color means that is trying to come up. I am ready to come up. Likewise, that is I mean. So this is not a shutdown state actually. And this port will not be able to do any kind of data forwarding. This not will be data, it will not do any data forwarding. This device will not learn the MAC addresses and all. This will be not learn the MAC addresses also. So listening state, it will be take 15 seconds of time, and there will be election, will be root bridge, entire election will be happen in this listening state, and root port and entire election will be happen in listening state. They once listening done, then learning, they will learn the MAC addresses. This will also take 15 seconds. And forwarding state means those states only forwarding the entire BPDU configuration. This is all about the STP, the basic STP. So here we have this is a spanning tree, a normal mode. And apart from that, we have a different modes. In advanced level, we'll discuss.
Lim, I have one question.
Yes.
In spanning tree protocol, it will take 1 minute for 15 seconds for each stage, right?
No, first you are in, see, we have a how many state actually?
Disable
5
state
states,
first.
right? First disable. Nothing it will be happen. Once connectivity we did, means the topology we configured likewise, it will be take minimum 20 seconds disable. Okay. And it will be learning state. Learning 15 seconds. After then listening, it will be 15 seconds. After then forwarding. So here it will be take 45 time convergence. The entire topology convergence, it will be take 45 seconds. So we don't want to waste our 45 seconds. That is the reason we are enabling port fast at where host. In host we are configuring. So apart from that, we have a RSTP. RSTP, rapid spanning tree protocol. In this protocol, we don't have this many states. So there we have some only it will be take the 15-second convergence only, fast convergence in this RSTP. In real time, we'll use RSTP only. I'm trying to explain that thing only now. Now you got it? These are the
Yes,
states. One more is
STP,
blocking
yeah.
state.
So RSTP will be find the shortest and the fastest path.
Yes, here we have this, not this many states. We have a least states compared to this. Okay, I'll show you that. In advanced networking, you can find out those things. So here we have a type some modes is CST mode, PVST mode, types of, these all are the flavors in STP, types of STP. And per VLAN, it is a PVST plus, and we have another one is RSTP. So first one is STP, spanning tree protocol. This is an open standard protocol. And after then, they introduce some new protocols in new types, because it is taking the 45 seconds. So if any topology changes occur, so loop avoidance part, it is taking 45 seconds, means 45 seconds is a more time in real time. It's a more, whenever in real time, 45 seconds means you cannot forward data, you cannot listen, you cannot do anything in that 45 seconds. See, if anything happen in this topology, so what I'll do, just I'll reload this switch. Before that, no shutdown will use here. So here only you can check. It will be take 45 seconds. Show spanning tree. So now listening state, after listening, it will become to forwarding state. Sorry, listening to learning. So we are wasting our timer here, learning. Once listening, after then learning, it will also take 15 seconds. You can check here. So here we are wasting. First convergence is 20 seconds. After then, once the convergence is done, in this convergence, they will introduce themselves BPDUs. In this BPDU, whichever the topology information is there, earlier we discussed, this is the information in the 20 seconds, it will be share and receive in this BPDU hello message. After then the message is done, the convergence, it will be take 15 to 15 seconds, listening, learning. So it will be take minimum 30 seconds again. So that is the reason we have a different flavors. So before that, we'll discuss one by one. So CST stands for Common Spanning Tree Protocol, and it is a open standard protocol again. And same 8.2.1d. So STP having one more version, latest version, that is CST, and it is open standard. And by default, CST will enable in non-Cisco switches. It will be enabled on non-Cisco switches, and PVST is by default in Cisco proprietary. PVST is a Cisco proprietary, and CST is a open standard. In different devices, we'll use this protocol. And in our topology, this is a Cisco packet tracer. So here running is a PVST, actually. PVST, per VLAN spanning tree, we'll discuss. So by default, CST will enable on non-Cisco devices, and it provide a separate STP instances for all the interfaces. It will be only one instance likewise for all the VLANs, and it does not support the concept of load balancing. It will be not support the load balancing. Guys, mute yourself. So it will send it will send one single BPDU for all the VLANs. It will be send only one VLAN for all the BPDUs. All the VLANs, it will send only one BPDU, and it will be having a single root bridge with for all the VLANs. Even though our network topology, we have one only root bridge. If you want to load balance, then we have a PVST method. Some benefits are there. So CPU utilization is a very low, and it uses .1q. We have a frame encapsulation method. So in that encapsulation .1q only it will be used, and it is an open standard also. And it has slower convergence. Convergence is slower. So it means 45 seconds it will be take. Just now what we discussed, 45 listening, learning, forwarding, disable. Those are the states these also having. Now move to the per VLAN spanning tree. Here we have a two types of version, per VLAN spanning tree, and apart from that, latest one is plus PVST plus per VLAN spanning tree plus. So it stands for VLAN spanning tree protocol. It's per VLAN spanning it stands for per VLAN spanning tree protocol. It is a Cisco proprietary, and it provide a separate STP instances each VLAN. If we have multiple VLANs, yesterday what we did lab, I'll show you on that how many VLANs are there. Yesterday lab. So here you can verify. So how many VLANs we have, that many instances. If we have 100 VLANs, that many instances we have. But here we don't have that many instances. Only one instances for all the VLANs. Only one instances for all the VLANs. That is the reason it is sending only one BPDU packet for all the VLANs. Here you can check for this switch. So enable show spanning tree. So here you can check how many. This is a VLAN 10, one instances, and here you can verify the by default priority. Then this is the root bridge also. In this is the root bridge. And if you want to change the root bridge, you can change based on the VLAN also. That is what load balancing. we can achieve load balancing. This is the second instances VLAN 40, and here you can check VLAN 50, VLAN 80, every VLAN having one instances. This is what one instances per VLAN spanning tree, per VLAN. This is a per individual VLAN, and it having the STP convergence. So even though if particular VLAN having one instances, that is what per VLAN spanning tree. So it provide separate STP instance for each VLAN, what I have shown. So it send multiple BPDU packets for multiple VLANs. It will be send multiple, how many VLANs we have, that many BPDUs it will be sent. It can having multiple root bridges for multiple VLANs. If you want to change one VLAN 10 part, one root bridge, another root bridge is different. So this is the root bridge for VLAN 10. If you want to change, this is for enable show spanning tree. If we have here, no, here not working because this is we configure different. Show spanning tree. So here you can check. So this many instances, if you want to change, so this is not a root bridge. You can verify this is a not root bridge. If you can verify, this is the root bridge. This one is a root bridge having MAC address. So if you want to change the root bridge for this VLAN 10, so this is a VLAN 10. So you can verify this is a not a root bridge. If you want to change, config T and spanning tree VLAN 10 and priority 4096. So decrease the priority. Now you can verify. Show it will take against timer. Topology changes occur here. So now it came to up somehow. So here we are using the span. No, earlier VLAN 10. Where is the VLAN 10? So this is the VLAN 10. This one is a last configuration. So here you can check. This is a port. No root bridge. Now you can check. This one is a root bridge. Now you can check. But are the, so here you can check. It is something happening. Election will be under. So this is a root bridge. Now you can check if you again show spanning tree. Yes, we can do that. If you want to change the root bridge for individual VLAN, we can change that. So this port is like here different. So that is the reason it's not showing. So fast Ethernet 0/4 forwarding. Now listening state. This one is a listening state. F0/2 something happening. So that port also, even though show spanning tree. So now you can check all are the ports are forwarding ports. All the ports are forwarding because election done earlier. Election was happened, listening, learning. That is what 15 second it will be take. Now you can check this is a VLAN 10 and this is a root bridge for this VLAN 10 and all are the forwarding state. So here VLAN 20, this is a not a root bridge for VLAN 20. This is a not a root bridge. Yes, based on the VLAN, we can change that. So that is what per VLAN spanning tree. By default, it is enabled on Cisco switches and it is a Cisco proprietary. So here you can check the only one is a root port, all are the designated ports. So here you can check all are the forwarding ports. So because this is a root bridge for VLAN 10. So CPU utilization will be high here due to maintaining separate STP instances. So CPU utilization, because here we have a multiple VLAN. If you have 10 VLANs only, that much CPU utilization. If you have thousands of VLANs, so per VLAN spanning tree, it will be happen. So that is the reason CPU utilization also more. So here CPU utilization is low because only one VLAN, only for all the VLAN, it is using only one BPDU packet or one instances likewise, it will be acting. So CPU utilization is less and here CPU utilization is very more and it uses ISL encapsulation to send packets. So comparison plus and comparison here. So here it will be used only ISL, but here it will be used .1Q also. That is the main difference in plus and PVST. Nowadays we are using plus only. So only difference is it will be it will be support .1Q as well as ISL also. PVST plus it will be support .1Q as well as ISL, but in PVST it will be support ISL only. And we can perform load balancing here, and it has slower convergence. Yes, it will be having slower convergence. Any doubts? PVST and PVST plus and CST. So only difference it will be support .1Q also. So now we are using here .1Q only. Encapsulation .1Q method only we are using. Show interface trunk. So here we are using .1Q method only. So that is the reason you can assume this is a PVST plus it is working here. Spanning tree version is PVST. By default version that is. So now move forward. So we have another protocol, another type. So rapid spanning tree, and it is open standard protocol IEEE standard 802W1W. Use this code, and it provide separate instances. It is also separate instances. It will send single BPDU packets for multiple informations and same convergence, entire thing same. But here we have a time convergence is little bit different. It will be take 15 seconds and 15 seconds compared to here 45 seconds. Here we have only 30 seconds only. Convergence is very fast. Even though not take that much time also in real time in RSTP nowadays we are using RSTP plus. So even though Cisco also using RSTP plus, it means it will be both. It will be support on both. PVST advanced version is PVST. Advanced version is RPVST. This is a Cisco proprietary, and this one is the open standard. Nowadays we are using this version, and entire thing is same, but only the states are different. The entire thing is same. So this is all about the, so everything is same. Apart from that, MSTP also multiple spanning tree protocols. We are not using this. It is an open standard protocol, and this is one S. This is all about the our STP topics. If you have any questions, ask me. I'll stop the recording.